Hello everyone, I'm Tian from Tongji University. I am honored to participate in this conference to share and learn knowledge about passive and low-energy architecture. Today, the topic of the paper I want to share is Influence of High-Density Mixed-Use Residential Neighborhood Building Layout on Building Energy Consumption, taking Chuangjifang in Shanghai, China as an example. The keywords of the paper are as shown. The paper consists of 4 parts. The second part is the main body, which includes idle block model simulation and energy consumption optimization of real block Chuangjifang. Different building layouts will form different shadows and ventilation between buildings, which will affect the microclimate and then affect the building energy consumption. Researchers in many regions have explored related issues. In this paper, the research location is Shanghai. Shanghai is situated in an area with hot summer and cold winter. And I chose high-density mixed-use residential areas as the research object due to its positive development trend. This study has been divided into 2 parts. The first part is field survey, guiding the user's energy use habits and building typical envelope parameters, and then setting the parameters of the simulation software, WUMI, based on the data obtained from the survey. Take the ideal block model and simulation object, determining constants and variables, establishing models, numerical simulation and data statistics, and finally, using the EUI as an evaluation index. The second part is optimizing the original plan of Chuangjifang community according to the conclusions drawn in the first part. WUMI is a new random series-based urban modeling design tool, which allows users to carry out operational energy, lighting, and walkability evaluations of complete neighborhoods. The underlying simulation engines are Energy Plus and so on. Its biggest feature is the algorithm of abstracted rapid multi-zone urban building energy model called Shoeboxer. To learn more about the Shoeboxer algorithm, you can read the references mentioned at the end of my report. The software considers diverse urban forms without losing geometric details, can obtain more reliable simulation results in a shorter time, and is more suitable for urban building energy modeling. This is parameter settings. This part is numerical simulation and data analysis. Select 4 neighborhood scale factors, namely height-wise ratio of urban canyon, courtyard aspect ratio, courtyard layout, and community functional distribution. In the simulation, these buildings were set to 3 types: residential, office, and retail, to study the influence level of different factors on energy consumption of different types of buildings. Take the EUI of the inner courtyard for comparison and analysis. It can be seen that as the heat-wise ratio of urban canyon decreases, cooling energy consumption increases, while heating decreases. On the whole, the influence of heat-wise ratio of urban canyon of north-south street on building energy consumption is more obvious than that of east-west direction. As heat-wise ratio of urban canyon decreases, the EUI of commercial buildings increases, while residential buildings generally decreases. The EUI decreases with the increase of courtyard aspect ratio. The change in courtyard aspect ratio has a relatively greater impact on the EUI of residence compared to model 0. The models with better EUI are 10, 9, 4, 2, and the models that perform poorly are 5 and 8. The trend may be building clusters with fewer east-west buildings have smaller EUI. In order to be more energy efficient, should we minimize east-west buildings and eventually turn our buildings into slabs like Model 10? The answer, I think, is negative, because the position of east-west building in the building group also has an impact on the EUI, and the introduction of a small amount of east-west buildings increases the energy consumption slightly, but it can also enrich the street space and pedestrian environment at the same time. The energy consumption of Model 5 is relatively good. So a reasonable functional distribution can also reduce building energy consumption. In general, business on the lower floor consumes less energy than when it is distributed throughout the building. Energy consumption optimization of real block Chuangjifang without changing the original planning path and the design concept. Only the east-west street width was increased from 26 meters to 40 meters, and the aspect ratio of each courtyard was appropriately increased. Retails are placed on the ground floor to the third floor, on which residential and offices are placed. The two layouts have the same proportion of building fraction, and the two models are similar in area. The simulation results can show that optimizing the layout of buildings and the distribution of building types can be used as one of the potential energy-saving methods. In the process of generating a plan, low-carbon energy saving is certainly a good vision and can be used as an auxiliary optimization method, but various factors must still be considered comprehensively. For example, in the optimization plan, in addition to energy-saving considerations, widening the main road has also expanded the crowded pedestrian space caused by tables and chairs outside the catering shops, so that the pedestrian street has a suitable scale. In addition, extending the distribution of shops to the branch roads beside the main road helps to attract the residents of surrounding communities, makes the branch roads also walkable, and expands the vitality space of the community. Due to the limited time, the previous results are no longer summarized. In terms of research deficiencies, the climatic conditions entered in the simulation should be the local microclimate affected by the building layout. In this regard, the software has its limitations. Except for solar radiation, other climate data such as wind environment and temperature have not changed with the adjustment of the building layout, so the results may be affected to some extent. Finally, the impact of a single factor on building energy consumption is still clear, but when the factors are considered in combination, more detailed simulation and sensitivity analysis must be performed. The research is supported by the National Natural Science Foundation of China, thanks to my tutor, Associate Professor Yang Feng, for his guidance and help on my paper, thanks to the teammates who worked with me on the field research. These are my references. If you want to know more about this, you can check the articles listed here. Thank you for your attention.